This video covers reporting category 3, day 2. I believe this is 17-5 notes. So the first thing we're going to talk about is direct variation. Anytime you see the words direct variation, it means you automatically have the point 0, 0 because direct variation goes through the origin. So the origin being the point 0, 0. So if you're given direct variation, you should set up a table and use the calculator. And then you could potentially see this as your equation. So for example 1, the distance a jet travels varies directly with the number of hours it flies. A jet traveled 3,420 miles in 6 hours. Write an equation to model this. So it's always going to be given to you as y varies with x. So I don't know if you want to write that down. But when we see this first example, we have the distance varying with hours. So hours is going to be our x and distance is going to be our y's. So we set up a table. We automatically have the point 0, 0 because of direct variation. And then we have 3,420 miles in 6 hours. I put this in stat edit. I don't need to show you that right now. Stat edit, and because varies directly is linear, we're going to choose option 4 for linreg. And we get this equation, y equals 570x. Now, to estimate how many hours it will take to fly that many miles, we will definitely use the calculator. So I'm going to open up my calculator. And we're going to plug this equation into y equals exactly like we see it. 6,500 miles is a distance. That is a y value. So 570x into y equals. I go to the table, so second table. I'm looking for 65,000 on the y's. And I don't see it. It would be somewhere in between 11 and 12 on the x's. So my answer would be between 11 and 12 hours because that's where 6,500 would fall. It would fall between 11 and 12 hours. So for example 2, we have an amount by which a string stretches is directly proportional to the weight that it supports. So the amount of stretch is my y because that goes before the word direct. So this is my y and weight is my x. Humberto hung a spring from a hook as shown in figure 1. He attached a 10-pound weight to the spring. It stretched 3 inches beyond its original length as shown in figure 2. If he attaches a 16-pound weight, which we're reminded is an x value, to the figure in 1, to the spring shown in figure 1, by how many inches will the spring stretch? So, first thing we need to look at in this picture, we have a 2-inch spring and then a 5-inch spring. Now it's important for us to remember this is the original. So when it stretches 5 inches, it's really only a change of 3 inches because it was 2 inches already to start. So we fill in our table. Because it's directly proportional, we have the point 0, 0, and then a weight of 10 stretches it 3 inches. So from the calculator, stat edit, we get this equation. Now, the question is 16 pounds. So if x is 16, what is my y? So in y equals, I'm going to plug in my equation. So I'm going to use the one with a decimal because I like decimals better than fractions, but that's up to you. I'm going to click second table. And again, my pounds are an x value. So for 16 pounds, we would expect it to stretch 4.8 inches. So there's a lot of words in that. Make sure you go back and reread if you need. but there's a lot going on. We took our direct variation and the information we were given, 10-pound weight stretched 3 inches, made a table, created our equation, and then put that equation in y equals to figure out the end. Okay, we have a little bit of vocab here. Sorry. So this time your vocab is mixed in instead of being at the end. So we have a little bit of vocabulary here. We have parallel lines and perpendicular lines. Parallel lines are lines that have the same slope and different y-intercepts. So here my slope is 2, here my slope is 2, and therefore they are parallel. As we can see from the graphs, they will never ever cross and keep the same distance throughout. Perpendicular lines are lines that have slopes that are opposite reciprocals, and we've called this, depending on your teacher, we've called this a flopposite or a flop because you flip it and make it the opposite sign. So here we have 3/4, here we have -4/3. Those are complete flopposites. They flip it and make it the opposite sign. We also have a little bit more vocab about horizontal and vertical lines. Horizontal lines have a slope equal to 0, and horizontal lines are parallel to the x-axis. Vertical lines have an undefined slope and are perpendicular to the x-axis. You have this Bucks Hoy, which is a supplemental aid that you have the option to put in your baggie. So if you have not put this in your baggie, but you want to after reminding yourself what this means, then you can go ahead and make sure you speak with your teacher at the end. So VUX is vertical line, undefined, x equals. Remember that x equals is the type of equation that you would see. And then Hoy is a horizontal line, slope of 0, and a y equals. So when you're asked about things parallel to the x-axis or perpendicular to the x-axis, the best thing you can do is to go ahead and draw a picture. The slope of a line parallel to the x-axis means it would look exactly like the x-axis, which has been labeled here. That would be a Hoy, and horizontal lines, as the middle part says, have a slope of 0. So you can write out the word 0 or put a 0 with the slash. If it was perpendicular to the x-axis, perpendicular means up and down. That would be a Bucks, and the slope is undefined. The slope of a line parallel to a y-axis would go up and down. An up and down line has a slope that is undefined. And then perpendicular to the y means it's going through the y, which would make it a horizontal line with a slope of 0. So we have a couple different equations of lines, some examples here. First, example 1 asks us to write the equation of a line in slope-intercept form that is parallel to this line and contains this point. So if it's parallel, that would use the slope of -3 because parallel means the slopes are exactly the same. And then they gave me a point, and through parallel gave me a slope, so point and slope. So we plug into point slope. Y minus 6 equals my slope that is parallel, which is -3, x minus 3. Okay, excuse me. From here, we distribute the -3. So -3 times x is -3x. -3 times -3 is 9. And then we solve for y by adding 6 to both sides and get the full equation. So for example 2, we are asked to write the equation of a line in slope-intercept form that is perpendicular to this line and contains the point. So very similar stuff, but this time perpendicular. Note, they've already shown us what the perpendicular slope would be. So -3 would flip, so 3 over 1 becomes 1 over 3, and it's the opposite, so we flop. We flip the fraction, and we make it the opposite sign. So negative 3 would turn into a positive 1/3. And then we're going to finish this out using point slope. So y minus 6, because that's my y1, equals my slope of 1/3, x minus 3, because that's my sine. So notice this time the only thing that's different is that slope. I'm going to distribute it, so 1/3 times x, 1/3 times negative 3, and then trying to get y by itself, add 6 to both sides. Remember, when you add 6, you only put numbers with numbers, letters with same letters. So 1/3 x needs to stay all the way down. The only part that changes is the b, the y-intercept, the number that follows. For example 3, we're asked to write an equation of a line that is parallel to the y-axis and goes through the point 3, 2. A sketch has already been drawn here for you, but guys, let me tell you, I sketch these every single time, and I have a degree in mathematics, but I sketch it every single time because while there's tricks to memorizing it, you don't need to waste your brain space. You got to remember parallel means looks the same, perpendicular means crosses. That's all you really have to remember. So you draw a rough sketch. 3, 2 is somewhere to the right and up. Doesn't have to be perfect. You don't need all the ticks. Parallel to the y-axis means it's going to look the same as the y-axis and will not cross the y-axis. I can see from the line I've drawn that this is a vertical undefined line. So it will need x equals the x from my point. And that's it. Do not make these problems more complicated than they already are. Draw yourself a rough sketch, figure out if it's a bucks or a hoy, and write your equation. Remember, the x from bucks tells you x equals, and then you just pull the x from your point. Now, when we are asked to write systems of equations, there's a couple of different things that we would need to use. So the first is if we're just writing, we're not asked to solve, we're just writing. Take two tables, put them into stat edit to get your equations. So since I haven't reviewed you on that yet, let's go ahead and do it on one of these. So we click stat edit. Remember to clear out anything that is listed in there already. And you make the table on your calculator look exactly like the table on your paper. Be very careful here because when you have two tables, sometimes we put our x's for this, but our y's for the, for something else. So just take your time here. So with my x's, I have 0, 1, 2, 3, and 4. For the y's, I'm doing table y1. I have 7, 6, 5, 4, and 3. So because I know that a system of equations is going to be linear, I click Stat Calc 4, and that's where this equation comes from. So they did that on both equations. Okay. If you're given a graph, take it one line at a time. This line crosses the y-axis at 1, so we do a +1, and then goes up 1, right 2, up 1, right 2, up 1, right 2, so it has a slope of 1/2. This equation crosses the line or the y-axis at -3 and then goes down 1, right 2, so it has a slope of -1/2. So for these problems, you're just writing your equations 2 times, and we did that on another assignment, on another notes. I believe it was RC2. So if you need practice with that, make sure you look at those assignments. So this one we actually will have to write something. So the perimeter of a rectangle is 72. The length is 6 inches greater than twice the width. And then they ask us to write the system that would represent the length L and the width W. So the first thing is that with the rectangle, we know that the perimeter is 72. And the way you find the perimeter is 2 lengths plus 2 W's. If you draw a rectangle, We have two widths and two lengths. It does not matter which one is on the side and which one is on the top, but you have two L's and two W's. You add them all together for your perimeter. So we've asked you to memorize it. You can also formulate the formula by drawing a picture. But your perimeter is 72 inches. So they took the formula for perimeter and set it equal to the actual perimeter. The other equation that we need, the length is 6 inches greater than twice the width. So remember, the word is means equals. Greater than is technically a switch word. So length is or equals. Greater than would go in the back. Twice the width would be 2W. Remember, with systems, all of the systems that you're going to see in algebra are two equations. So if you finish a problem with a system of equations and you have lots of pieces of information, but you only have one equation, that's not right. Also remember, with systems, once you use the number, you cannot use it again. So when I use 72 in that beginning part, I can't use it again. The only exception is if they repeat numbers or if it's a formula that you have to use, like 2L plus 2W, and here we have twice the width. But once you use this twice, you can't use it again. Once you use 6 inches, you can't use it again. So I wouldn't somehow put a 6 up in here as well. Once you've used the information, you cannot use it again. So, in order to solve a system of linear equations, we talked about the 3 different types of solutions the other day, but a system is simply 2 or more equations that you can solve or graph at the same time. The solution is the point where the two functions intersect, so the point where they cross. That is all you are looking for. So for this first example, we have 2 lines, but we cannot see where they're crossing. We know that this line crosses the y-axis at 1 and goes up 1 right 2, so it has the equation 1/2 x plus 1. And this equation down here crosses at -3 and goes up 1 over 1, so it has a slope of 1. So I'm going to take those 2 equations and put them both in y equals to see exactly where they cross, because I can't see it on here, but I need to figure it out. So remember, if we do alpha y equals enter, we can type in a fraction. So 1/2 x plus 1 and 1x minus 3. Remember, this 1 in front of the x does not have to go there because the x shows that there's a 1, but things like plus 1 where they're by themselves, you do need the 1. So I click graph and I can see where it crosses. So we have 2 options here. One option is to click second table and look to see where your y's are the same. I'm looking for where my y's are the same. It might be up here because I can see it on the graph. Oh, look, there my y's are. The other option is to click second trace 5, enter, 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 and it will tell you the solution as well. A third option would be to get some graph paper and keep this graph going and going and going, but that's probably the most tedious option. So again, the 2 ways I did it were second table, and I'm looking for where my y values are the same for the same x, or second trace 5, enter, enter, enter. So enter 3 times. If you need to pause the video to write those steps down, please do. Over on the other side, we can very quickly see our solution. The point where the lines cross is the point 1, 3. So we simply write that as our solution, and that's all we have to write and do for that problem. So as we talked about the other day, you can have one solution because there's one point where they cross, no solutions because they're never going to cross, or infinite solutions because the 2 lines are on top of each other. Now, you want to mark these steps. I'm going to go through them on the last page, but you want to make sure that you know how to put these systems into the calculator because that's the easiest way to do it. There is a note down here. If you complete all 8 steps and you get something where the whole bottom row is zeros or the whole bottom row is zeros and then a 1, that means infinitely many or no solutions. So we have these solutions to go through. So, in my calculator, remember that first you have to start off with your answers being in standard form. Okay? So both of these are already in standard form because my x's and y's are on the same sides together. I have them lined up perfectly. They're not only on the same side, but they're perfectly lined up, which is perfect. So my x's go here, my y's go here, my answers go here in standard form, perfectly lined up. So they've given us the answer, but I want to refresh your memory on how to do this. So we click the second button up in the top left, and you see the little blue matrix button. We want to use matrices, so we're going to click matrix. Now, just to refresh your memory, I am clicking these steps here. So I've clicked second, x to the negative 1. I scroll to the right to go to the matrix math menu. I'm going to follow step 3, which says to select B, which is the really rapid equation fixture, the RREF. So I've scrolled up until I hit B. You can also scroll down until you get there. So I'm going to select that option. From here, I'm going to click Alpha Zoom. My matrices are always going to be 2 by 3s. So I'm going to click 2 and 3. Once you have these highlighted, these will naturally pop up, but your go-to when your calculator is cleared is a 2 by 2. So you want 2 on the rows and 3 on the columns, and you click OK, and this whole thing pops up. So to plug it in, I put the numbers exactly like I see them. So I see a 1, and I use the arrows to go over. -1, arrow, -6, arrow, 2, arrow, -3, arrow, and 16. Now again, this answer was already here, but I want to refresh your memory on those steps. So we have -1, 0, 0, 1, 0, 0, 1, which is exactly what it's supposed to look like. This tells me that I have a great solution. That is perfect. My solution is these numbers tilted to the side. So -34 goes first, and then -28. So let's practice on example 2. The first step is to put your equations into standard form, and this is not in standard form. So over here, we've moved -5x to the other side, so we have -5x plus y equals 1. So I'm going to use that equation. And my original equation, and you don't necessarily have to rewrite these, I just want you to see exactly where my numbers go. So I plug my numbers in with no letters exactly like I see them. So I see -5, 1 in front of the y, 1, -4, 1 in front of the y, and 10. Again, my steps to get the answer, even though the answer is already shown, is second, matrix, scroll to math, scroll to B, alpha, zoom, 2 by 3 is already selected, so I click OK. -5, arrow, 1, arrow, 1, arrow, -4, arrow, 1, arrow, 10, arrow. Ooh, and this does not match what's on our paper. Oh, because I invented a negative. So if you make a mistake, second enter gets you back to what you originally typed. And there we go, now it matches. So my solution is a nice normal solution of 1, 6. Okay, now we have 2 last problems left, and apparently when we complete them, we can see that these are not great things. They don't work nicely. So we're going to go through the steps because the matrices are already set up, because I want to review this with you many, many times. So second matrix math, scroll up to B, enter, alpha, zoom, okay. And then we have 1, arrow, -1, arrow, 1, arrow, 3, arrow, oops, sorry. -3, arrow, 3, arrow. And this is what we see exactly from the calculator. So this tells us that we have infinitely many solutions because of all of the zeros down at the bottom. So infinitely many, which means my equations are exactly the same. And if I were to plug them in, I would only see one line when I graph it because they're right on top of each other. All right, and then the last piece, one more time over here, we change this one to standard form. We move the y to the other side so it becomes negative. Second matrix, math, really rapid equation fixer, enter, alpha zoom, okay, 1, -1, -1, -1, 1, -1. When I click enter, the bottom row on the answer is 0, 0, 1, which means there are no solutions. Okay, so a quick reminder, we need to do the really rapid equation fixer in order to find the answers to systems of equations using matrices. So make sure you know those steps backwards and forwards because you will have to use them on the EOC and you will have to use them on your test 17.